Hey students, in this video I'm going to explain how to graph a system of linear inequalities. Okay, so first to graph a linear inequality you need to have these equations, turn them into from standard form into slope-intercept form. So first I'm going to write the first one, and we want to have y by itself. That means that this 4x does not belong on the left side of the inequality, so we subtract 4x from both sides. And we end up with y is greater than or equal to, we want this to replicate the form of mx plus b, slope-intercept form, so we want to write the negative 4x first, followed by the positive 1. Next, we notice that the y is by itself, so that we don't need to do any other additional steps to this. This is already the inequality converted into slope-intercept form. Okay, so for the next one, I'm going to have negative 3y plus x greater than 3. This one is not necessarily in standard form because standard form tends to have the x term first, but it doesn't matter because the goal in mind is to have the y by itself. So that means that this x does not belong on this left side. So we're going to subtract x from both sides, bring down negative 3y, rewrite these two terms in terms of mx plus b. So the negative x goes first, followed by positive 3. And then we need to get this negative 3y to become a y by itself. So we're going to divide by negative 3. Each part is divided by negative 3. And now whenever we divide by a negative, we need to flip the inequality sign. So we have y is less than, and then when there's no number, there's a 1 in there. So that's negative 1 divided by negative 3, which becomes positive 1 over 3, x. And positive 3 divided by negative 3, that's negative 1. So this results as the final conversion of this inequality into slope-intercept form. So now that we have turned these into slope-intercept form, we're going to be able to sketch them by hand by identifying 4 things. We need to find the y-intercept. This is where we're going to start by plotting a point on the y-intercept. And then we need to then identify the slope, which is the m value. And this is how it's going to tell you how to move from one point to another. The rise over run ratio. So having it as a fraction is better, so that can help you move from one point to another. Besides y-intercept and slope, you need to also identify what that symbol of inequality tells you. With what type of line are you going to have, if it's going to be dashed or solid, and then where are you going to shade, what direction, above or below. So first of all, if this is mx plus b, the y-intercept is identified on the b value. That means you're going to have a positive 1 as your y-intercept, and we're going to have a point here on when the y-axis a positive 1, we're going to have a point right there, positive 1. Next, we're going to have the slope. The slope is negative 4, but we prefer to have it as a fraction, so negative 4 over 1. This slope is going to tell us that we're going to rise down 4 spaces and run 1. Rise over run. So from one point to another, we're going to rise down 1, 2, 3, 4, and run 1. And then go ahead and mark a point right there. Rise down 1, 2, 3, 4 spaces and run 1. We can do this backwards. So up 4 spaces, 1, 2, 3, 4, and then left 1. Up 2, 3, 4, and then left 1. So this creates the angle for that line, but we're gonna first decide if we're gonna draw a dashed or solid. So you may recall that in order to have a solid line, we need to have the inequalities that are equal to. So the less than or greater than or equal to, those create that solid line. If we have the inequalities that are just less than or greater than, those create a dashed line or dotted. Based on that, we can conclude that this inequality is going to have a solid line. So we're going to draw a solid line through this point. Again, this is just a sketch. And now we need to decide where to shade. So to decide where to shade, we need to recall that the inequalities that are less than or equal to, these are referring to values that are lower in value. So we're talking about less than, so this is below. I'm talking about y values that are below any other number. If we have the opposite, greater than or equal to, this is above because this is greater. I just like to explain this to my students to look at the y-axis and know that the y values that are greater are above and the y values that are lower are below. So in this case, this inequality symbol is going to be greater, which means above. All right, so we're going to shade above, meaning up here, any value above the line. So all the solutions for this inequality are in this shaded area. And because this is a solid line, they're also in this point. In this line. All the points in this line are solutions. All right, let's try the other one. We are going to draw or identify the y-intercept first. So the y-intercept for this one will be -1. And this is where we start. So I'm going to start at -1. I'm going to use another pen just to differentiate the color. So -1. And then the slope for this one is going to be 1/3. So we're going to rise over run, rise 1, run 3. Rise 1 up, run 3. So rise 1, run 3. Rise 1, run 3. If we run out of space, we go the opposite way. Down 1, left 3. So now we decide what type of line we're going to have. So this goes based on this symbol. This symbol, we said it was going to be a dashed line. And then we also said that this symbol, it's going to show is that we're going to shade according to this is less, so below. And one thing I want to point out is that here, because we divided by negative, we have to flip the sign. And this is the one that you make a conclusion out of, not the one given, because this is standard. So always make the conclusion of what type of line you have and where you're going to shade once you turn it into slope-intercept form. So first convert it before you identify these 4 things. All right, so we're going to shade below and draw a dashed line. Now, because this line is dashed, that means that points on this line are not going to be solutions. Okay, so an example of solutions, we're talking about in the double shaded area. This part right here. Go ahead and highlight that. So this area right here. This is where the solutions are for this system of inequalities. Okay. For example, we're looking at 0.5, -2. This is a solution. Not a solution will be considered any point that is not here. Also a point on the line because it's dashed. But if the line is solid, it is a yes. If the line is dashed, it's a no. Also, anything on the non-shaded area, it's a no. So for example, we can say that the point 0, 0, the origin, that is not a solution. We can also say that the point right here on this line, that is 6, 1, that is not a solution. And then the point right here on this solid line is a solution. So for example, +1, -3, that one will also be a solution. So that's the challenge. Just once you have this graph going, identifying where the solutions are. I hope this video helps.